So here we are in Unit 2. We're going to start off by solving these multi-step equations. And so you'll notice in this section, we are given a variable, and you'll see them all here. There's one variable in that equation on one side of the equation. One variable on one side, and our objective here is gotta isolate it. We are isolating the variable. That means, folks, we're getting that variable by itself. So let's look at some of these nice warm-up problems. Like one, for example. I'm hoping from the first unit you remember. A negative times a negative is a positive. So this is the equivalent statement as x plus 9 equals 7. What is it that we want to do? We want x alone. How do I get x alone? Well, it's currently being added to 9. So I want to do the inverse. I want to take that 9 away from that x. So on both sides of the equation, we are going to subtract 9. I bring this x down, along for the ride. 9 minus 9 goes away, which is what I wanted. And then I've got 7 minus 9 leaves us with negative 2. So for question 1, our x is negative 2. So now let's look at 2. In 2, I want to solve for d, not negative 3d, just d. So similar to 1, there is something that is attached to my d, and that's the negative 3, but it's not attached by the same operation. Negative 3 is being multiplied to d. So what do I want to do in this case? How do I get rid of something that's multiplied? Yes, I'm going to divide both sides by negative 3. And if we do that, and I'm going to write it as negative 2418 divided by negative 3, and there it is. It's telling us, oh, that answers 806. Whoops. So I know that my d, and it's a negative divided by a negative, so I know positive 806. So I'm going to have you try an example. Let's look at 4. So 4 is similar to 2. I know I skipped 3. That's fine. 4 is similar to 2. I want to solve for w. However, there is a negative 2/3 attached to my w by multiplication. So folks, I'm going to show you two things. Here's one thing we could do. We could divide both sides by negative 2/3. What is the same operation as dividing by a fraction? Dividing by a fraction is the same as multiplying by that fraction's reciprocal. So here's another way that we could entertain this problem. We could look at this problem as multiplying both sides by the reciprocal of negative 2/3, which is negative 3/2. And here, look at this fraction power. 2 and 2 cancel out. The 3 and the 3 cancel out. So do those two negatives, which is nice and clean. That leaves me with what I wanted on the left side, w by itself. And here, I can either multiply straight across. Negative 16 times negative 3 is positive 48. 2 times 1 is 2. And we could also just use Desmos for that as well. And we end up with w equals 24. Dividing by a fraction is the same as multiplying by that fraction's reciprocal. Lovely. All right. Now, let's look at 5. 5 looks a little different in that there is a multi-step operation going on. So, folks, I'm still trying to isolate that variable. I want n by itself. So I might first start by getting rid of anything that is being added or subtracted to that variable. And what do you notice with 5n plus 8? I want to get rid of that plus 8. How do I get rid of plus 8? We sure do. We minus 8 from both sides. So now that goes away, 8 minus 8, that leaves me with 0. I bring down my 5n equals, and now I take the sum of 122 plus negative 8, or just negative 122 minus 8, and that gives me negative 1, 3, 0. So now I've got a problem that looks similar to the earlier ones. Now what is being attached to my n? The 5, and it's being attached by multiplication. So how do I get rid of 5? That's the 5 that's being multiplied to n. I am dividing. 5 over 5 is 1. That leaves me with n isolated. Wonderful. On the left side. And now I just do my math. I can pull up Desmos if I want. And I know that negative 130 divided by 5 is negative 26. And Desmos will validate that. Now 6 might look different, but you know what I'm going to do here? I'm going to rewrite this, folks, as negative 1/5 g plus 3 equals negative 13. Because g divided by negative 5 is the same as negative 1 over 5 times g. So I just rewrote that first term. And now I'm going to do the same procedures that I did in 5. I want to get rid of anything that's being added or subtracted to my variable. So step 1, we want to get rid of that plus 3. And so on both sides of the equation, we are subtracting 3. So this comes on down, gives us negative 1/5 g on the left side, and negative 13 minus 3 gives us negative 16. I'm going to rewrite that up here. All right. So then our next step we might notice is I've got negative 1/5 g equals negative 16. I want g by itself. So I could just take negative 1/5. I could divide both sides by negative 1/5, but what's the same as dividing by a fraction? Multiplying by the reciprocal. Multiplying by the reciprocal. So here, 5, 1, 1 goes away. The two negatives, same. Leaves me with g equals, and now just to make this clearer, I'm going to put 16 over 1. So I have negative 16 over 1 times negative 5, and that leaves us with some Desmos work, but I think that gives us positive 80. What I do want you to also appreciate is if we ended up with 80 as our solution in 6, and we can do this with every single one of the problems. That means if I were to plug 80 into the left side of the equation, with everything else, I should get the equivalent of what's on the right side. Let's do it. So if I plugged in 80 divided by negative 5, scroll to the right, plus 3, and look at the result. We get negative 13, which is what we have on the right side. Skipping around again, so let's look at 8. So I'm seeing with 8, oh my goodness, the variable's on the other side of the equation. That's okay. So what we end up looking at is, and please identify this with me, that it's not just the variable that's being divided by negative 6. It is the entire right side of that equation. It is the s and the plus 12 that's being divided by negative 6. So here is what we want to do instead. Because I have negative 6 in the denominator, I want to get rid of it because I want s alone, and that whole side is being divided by negative 6. So in this instance, I'm going to multiply, and I'm going to put it over 1 so it's clear to all of us. I'm going to multiply both sides by negative 6. And so look at this. That allows me to cancel out these two negative 6 because the entire side is being divided by negative 6, so wiped out. So that negative 6 is gone. That leaves us with s plus 12 on the right side. And then, let me get rid of this. And then I've got 14 and 6, or negative 14 and negative 6. Math it out. That gives me positive 84. So then our next operation is, remember that's my variable, I want s by itself, and it is currently being added to 12. So I want to use the additive inverse, the opposite of what addition is, to get rid of that. So that leaves me with S equals, and then I take 84 minus 12, and that gives me 72. And look, folks, I'm going to use my symmetric property of equality. If 72 equals S, then S equals 72. So let's look at 12. I put it here just so that I have more space. In 12, there are just multiple things happening, and it looks very busy. But our objective is, let's isolate those variables. So I want all the variables on one side, all the constants on the other side. So I'm going to pick a side. And it looks like I'm going to keep the variables on the left side of the equation. So for starters, I want to get rid of this 1/2. It's being added. So I hope we're all in agreement. I am then going to subtract 1/2 from both sides of the equation. Boom, boom, that's gone. Bring on down the 3/4 x, bring down the minus 1/3 x, and now I have negative 1/4 minus 1/2. So if we wanted, we could write it just like so. And it's telling us it's negative 0.75. And remember, folks, that's negative 3/4. So I can combine that as negative 3/4. And now I have these two like terms that I need to combine. So let's see here. I've got 3/4 x minus 1/3 x. I could get a common denominator, or I could then use Desmos again. And I could ask, what would 3/4, escape, minus 1/3 leave me with? And that is a messy decimal, but if I ask for the fraction form, that is 5/12. So this cleans up nicely to 5/12 x equals negative 3/4. And what did we say, folks? What's this? Oh, whoops, I lost my x. What way can we get rid of the 5/12 that's being multiplied to x? We're going to multiply by the reciprocal of that coefficient. We're multiplying, folks, both sides by 12/5. And you'll notice 12 and 12, 5 and 5, leaving us with what we wanted, x on the left side. This, again, plug into Desmos or use your number sense. I see 12 in the numerator and I see 4 in the denominator, and I know if I divide both of those by 4, look at that, leaves me with 3, so I'm going to clean that up. It looks like negative 3/1 times 3/5, and then I just have top times top, bottom times bottom, and that gives me negative 9/5. And if we plug that into Desmos, you can see right down there, negative 3/4 times 12/5 also leaves me with negative 9/5. So let's end this on 11. So here we've got this statement, and I'm hoping first thing you're identifying is, oh, I got this negative 4 that wants to be distributed to the two terms inside the parentheses. So everything else comes down, negative 4, and now we're sharing the negative 4 to both things. Negative 4 times f is negative 4f. Negative 4 times positive 6 is negative 24. Bring down that plus 14. So here, let's identify. I think on the right side we have like terms. So we have 20 equals negative 4f. And now I'm taking negative 24 and adding positive 14. I'm adding 14 to negative 24, and that leaves us with minus 10. And I'm hoping that you're seeing this term and this term. Those are my two like terms. I want to combine them. I want that f by itself. I want to get rid of that minus 10. So what do? The opposite. I am adding 10 to both sides because, shoop, that goes away. That leaves me with negative 4f on the right side. Now let's look at the left. 20 and 10 is 30. Now I'm going to bring this over here. and I see that I have 30 equals negative 4f. I want f isolated. Negative 4 is being multiplied, so I want to divide both sides by negative 4. I'm going to use my symmetric property here, folks, and I'm going to switch it and say that f equals negative 30 divided by 4, which can simplify, 2 goes into both of those, as negative 15 halves.